All right, hello. We are here getting ready for summative number 10. First thing on the summative is special rate triangles, and you can use your green sheet. But to get us going, let's look at what kind of formulas we're going to need. So 45, 45, 90 is the first kind of special rate triangle we learned about, and the first one you're going to be tested on. So pretend that this is most definitely a 45, 45, 90. And the way the pattern works is you've got two legs that happen to be the same size, because if you have a 45-degree angle, you have an isosceles triangle. So then the hypotenuse is whatever the leg length is times the square root of 2. So using that pattern, you should be able to figure out these missing sides to these following triangles. So like for instance here, we got the hypotenuse, which is 5 square roots of 2. Well, that means our legs must be 5. Over here, the clue they give you is that this leg is 10. All right, so that means this leg has to be 10. And then the hypotenuse is whatever the leg is times the square root of 2. So it's kind of a game of looking for the clues they give you and just kind of filling in what you know. So another 45, 45, 90, this leg is 3, so that means this leg is also 3. And then the hypotenuse must be the leg times the square root of 2. And this one's a little strange. The leg is 2 square roots of 2, which means when I go to find the hypotenuse, you're going to take the leg, 2 square roots of 2, and then you're going to multiply it by another square root of 2. So this becomes the square root of 4, which is just 2. So you end up with 2 times 2, better known as 4. So that was a little unusual. None of these questions had that weird case where the hypotenuse didn't look right and you had to do some clever division. We're not going to do that to you on the test. I'll give you a little heads up so you don't have to stress about that. Now the other type of special rate triangle is a 30, 60, 90. So you're going to have a 30-degree angle, a 90-degree angle, and a 60-degree angle. And across from the 30-degree angle is what I call the little leg. So I'm just going to call it LL for short. The hypotenuse is whatever the little leg is times 2. So it's double whatever the little leg is. And then this medium leg, the one that's across from the 60-degree angle, is whatever the little leg is times the square root of 3. So the pattern's a little strange, but you get used to it. So like for instance, number 5 here, the clue they give you is that the little leg is 4. So then an easy thing for us to figure out then is the hypotenuse, which is double that, so that's an 8. And then that medium leg is whatever the little guy is times the square root of 3. So I always like to say the little leg is the key to the problem. If you can find the little leg, then you know everything. So when I look at my next question, the clue they gave me this time was this medium leg, and it said, oh, the medium leg is 8 square roots of 3. So remember, the medium leg is little leg times square root of 3. Well, that means the little leg must be an 8. And then once you know that's an 8, then you know the hypotenuse is double that, which is a 16. All right, next guy, the clue they give you here is the hypotenuse, which is 16. Oh, that sounds familiar. You're going to cut this guy in half to get the little leg. And then the medium leg is little guy times square root of 3. That ended up being the same triangle as the previous question. They just give you a different set of clues every time, so you got to think on your feet. And then this last one's a little strange. The little leg is 1/2. And then the hypotenuse is going to be that guy times 2. So if you think about 1/2 times 2, that's going to be a 1. And then the medium leg is this little guy times the square root of 3. I actually don't mind this as an answer. What a lot of people will write is they'll sneak the square root of 3 up in the numerator and write square root of 3 over 2. That is going to be a friendly ratio that you'll see a lot when you take a trig or a pre-calc class in the future. All right, now we're back to right triangle trigonometry. So we have sine, cosine, and tangent. Remember, you do have those formulas given to you, but this is the mnemonic device that will help us figure out whether which ratio we're using. All right, I'm going to pause for a minute while the pledge goes. Okay, so in my opinion, the key to this problem is to figure out where you're standing in the triangle. So it's whatever angle they give you, or in some cases, what angle you're trying to find. So this is you standing over here at 39 degrees. And then you have to label the sides of the triangle in reference to where you're standing. Now the hypotenuse is never going to move. So first thing I try to figure out is where's the hypotenuse? So this 18 over here is the hypotenuse. And then across from you is what they're calling side x, which is what you're trying to find. So we call that opposite. So when I look at my trig functions, we seem to be setting up what's called a sine ratio. So the sine formula says the sine of the angle, which is 39, equals, and then you have to follow the formula. It's opposite over hypotenuse. So opposite is x, and the hypotenuse is 18. And from here, you just got to trust your algebra brain. You have a proportion. So when I solve a proportion, we typically cross multiply them. So you're going to multiply by 18 over here on sine of 39. It doesn't matter which order you do this on your calculator, but you got to make sure that you get in the habit of closing the sine function with your parenthesis over here. And one more thing, make sure your mode, check your mode, guys. You got to be in degree mode. So if you go to the mode button, make sure degree is highlighted. And at this point, this just becomes a typing problem. We don't expect you to have those memorized by any means. In fact, back in the day, you'd have to use a big old table in your book. Speaking of which, I wanted my calculator out, but I do have the key. And turns out this guy, oh, sugar, I never solved this. All right, let me find the calculator. 18 times sine of 39, just type carefully. You're getting about 11.32. And that's our answer. All right, so let me see how many of these there are. I'm going to skip around a little bit. I'm going to move down to number 11 now. Actually, no, I lied. I'm going to do number, 11's fine. Okay, so once again, we're standing over here at 39 degrees. Same place, same angle, but you notice we have some different clues. This time the hypotenuse is the x, and then the 10 is located in the side that's next to you, but not the hypotenuse. We call that the adjacent side. So that gives us a cosine ratio. So the cosine of our angle equals adjacent over hypotenuse. So once again, once you get your ratio set up, now it becomes an algebra problem. It still is a cross multiplication problem, but what's unique this time is it's x times the cosine of 39, which is nothing I can type on my calculator at this point. So we do have a little bit of algebra manipulation that's going to happen. So equals 10. And you think, all right, I'm trying to solve for x, which means I have to divide by this number that's being multiplied by x. So let's divide by the cosine of 39. Ooh, got a little weird there. Let me fix that. Now, of course, we got to do it on both sides of the equation. That's what allows us to solve it. So on my calculator, I'd be typing 10 divided by cosine of 39. And that's how I'm going to get the answer of like 12.9. I don't know where it said to round. I'm probably not rounding right, but that's okay for now. All right, more right triangle trig, but this time you'll notice they don't give you the angle, but they do give you a place where they'd like you to find the angle. So this is the angle that they want you to find. So this is going to be where we're standing over here. So once again, I'm thinking about, what information do they have labeled here? 8 is the hypotenuse, and then 6 is totally across from you, so we call that the opposite side, which means we're looking at sine. So this time, sine of they don't tell you the angle, so you got to put like a variable there. I use x, that's fine. And then equals the opposite over the hypotenuse. So now we got to go back to our algebra roots and say, how do I get rid of sine? Because I'm trying to solve for x. Well, to undo a function, you have to use their inverse function. The inverse sine function undoes sine. But algebra says if you do something to the left side, you got to do something to the right side as well. So kind of cool over here, sine inverse sine cancel, and you just get x. But over here, this becomes sine inverse, and then you got to type this in your calculator. Sine inverse of 6 over 8. So second sine is how you get sine inverse, and then 6 divided by 8 gives you about 48.6 degrees. All right. So anytime you're finding an angle, you're going to need to do an inverse trig function. Let's take a look at, skipping around, I know. Let's look at 14 real quick. Same idea. This time this is the angle that we're trying to find. So I think about, all right, who do we have here? There's no hypotenuse given, which is a dead giveaway that we have tangent, but let's look at why it's tangent. 22 is opposite of you, and then 18 is adjacent to you, and that's the other reason why we have tangent. So we're going to be setting up the tangent of mystery angle, I'll call it x, equals, it has to be in this order, opposite over adjacent, so 22 over 18. So just like with sine, we got to undo tangent function this time, so we're going to use our inverse tangent. So same thing as sine, just got to use the right button this time. Both sides of the equation, inverse tan and tan will cancel. And now you just got to carefully type inverse tan, so second tan of 22 over 18. I'm getting a 50.7 degrees. Seems appropriate. I like it. You'll know if your answers are weird, like really weird, because they just won't make any sense at all. Unfortunately, it doesn't account for uncareful typing. So I would suggest to you guys to be very clear in your algebra on your paper, and that way if you have a typing issue, I can still give you quite a bit of credit for that. Now here we have a cable that's at the top of a tower. So I'm not going to draw a real elaborate picture, because I can't. But, you know, it's going to make a right triangle. I will tell you on your test, the picture's already drawn for you, but you got to label it. So a couple of clues. The tower is 250 feet, so the height of the tower is 250. And then the cable itself is 300 feet long. Remember, they said it connected from the top to the ground. So this right here is the cable. And they want to know the angle that it makes with the ground. So they want this angle right down here. So this is going to be our point of reference. And we have to figure out what trig function we have here. So this is the hypotenuse. And then this is opposite of you. So it looks like we're looking at a sine function. So sine of that angle equals opposite over hypotenuse. So just like a few problems ago, we have to undo sine by using an inverse sine. So we are inverse sining, applying an inverse sine to both sides of the equation. Over here, they just cancel. And then over here, we just got to type. Inverse sine of 250 divided by 300 in the sine function, inside the inverse sine function. And I'm getting a 56.4 degrees, which, again, seems logical for an answer. I know my picture is scrappy, but I don't think it's a crazy answer. Okay, so now we're looking at some old concepts, but they're very important to your final that's about to show up. Plus, you're going to get a brand new score in Skyward, which a lot of you needed new scores for this section. So we have two functions given up here. We have f of x, and we have g of x, and they're going to want me to perform a few operations on them. The first one being to take f of x and add it to g of x. Well, y'all, that's simply just an adding problem, but that doesn't mean you should go like fast and not show any work. I still want you to show work. Always show work. Slow yourself down to the point where you don't make goofy mistakes. Now, this would not be an okay answer because you have some combining of like terms you need to do. So we have 4x squared plus x, those don't combine, but then you have -3 and a -2, which will combine to a -5. I don't really care what order your terms are in. It doesn't have to be in standard form, but they do have to be simplified properly. This is the one I'm most worried about because we're going to be subtracting function g, and you have to remember to subtract the whole function. So f of x, nothing weird there. But when you subtract function g, you have to remember to subtract the whole thing, and parentheses are going to help you do that. So instead of trying to remember to subtract everything, because you guys kind of mess up double negatives often, go ahead and distribute the negative, and then it becomes an adding problem. So 4x squared minus 3, still the same thing, but now you have a -x and then a +2. So now when I go to simplify and collect my like terms, these are still the like terms we're going to collect, but obviously you can see that there's some signage differences from the previous problem. So we have 4x squared, this time now minus x, and then -3 plus 2 is a -1. So watch the distribution of your negative on a subtraction problem. All right, next question, a little dot in between the functions simply means to multiply. But because we have binomials, you're going to have to remember to use parentheses on both of them, so that way we distribute. Again, slow is the name of the game, so let's do this. We got 4x squared times x, which will be 4x to the third. And then 4x squared times -2 will be a -8x squared. -3 times x is -3x. And then -3 times -2 will be a +6. Now normally we have some like terms right here we have to combine. That's not the case in this problem because our first binomial was a quadratic, which was kind of weird. But that's okay. The idea still applies. We're going to distribute using parentheses. You guys used to call that foiling when you were little kids, but you know, it's distribution. All right, and finally we have what's called composition. This is a composition question. And once you know the trick to these, they're not too bad. And the trick is you got to start on the inside. So the first thing you're going to find for me is g of 4. So you go up to function g, and you plug in a 4. So 4 minus 2, which is 2. And now the function says f of whatever you just got. Oops, I crossed off f. So the second thing you're going to do is find f of what you just got, which is the 2. All right, we can do this. So here's function f. And I'm just going to plug in the 2 you just got. Oh, for goodness sakes, guys, use a calculator. Order of operations says you do exponents first. I have so many people telling me this is 8 squared, and that is just not how you do things. So 2 squared is 4. 4 times 4 is 16. 16 minus 3 is 13. The answer to this question is the last number you get, which is 13. So composition of a function, add a number. You start on the inside, find that first number, and then keep plugging in and work backwards from there. All right, really old topic from logarithms, but definitely something we need to see. We're going to be solving exponential functions. My suggestion to you at the top is look for common bases first, because we found out the other day that that's actually a lot easier to do. If not, you can always use logarithms, and in some cases you have to use logarithms, and we'll see that in a moment. So number 22, you know what? I think we got a common base. 343 and 7. Well, 7 is a 7. That's not going to change. But 343, you could rewrite it so that it is 7 to some power. And you might want to test some stuff out on your calculator, or you can use that chart if you have it. But it's 7 to the 3rd power. Now the reason I wanted to look for that common base is because this becomes a really easy question now. Once you have the bases matching, the only way for these to equal each other is if these equal each other. So the exponents have to be the same. So 2x minus 1 has to equal 3. We're going to add 1 to both sides. 2x equals 4, so x equals 2. So the common base method is awesome, right? Super easy. I'm going to show you a secondary way to do that question because this might help you get some bonus questions on an extra credit question coming up. So let's say I don't like the baby base method, common base method, and I have another idea. Well, one method that will always work is to apply a logarithm to both sides of the equation. Now, it could be any kind of logarithm. I always suggest that you guys use common or natural. Excuse me. Just because we have buttons on our calculator that are common and natural. So I'm going to go ahead and use natural log. Well, actually, you guys always ask for common log. I'll use common log. So look what happens when you apply a logarithm. This is a log base 10. Now, nothing cancels. Nothing happens that cool. But what logarithms do is they take exponents and they drag them down in front. So this 2x minus 1 is now in front of this common log of 7, which is just some hideous number. And then over here, remember you applied the log to both sides to keep it, mathematically balanced, and you got the log of 343. I'm going to add some parentheses here because your calculator uses parentheses. So just remember, log of 7, some hideous number, log of 343, some hideous number. So if I'm trying to solve for x, what I could do now is I could divide this log of 7 over to the other side. And you'll see something kind of cool happen at this point in our math, where it kind of parallels the baby base method in a moment. So these are gone. You got 2x minus 1. And then when you type log of 343 close divided by log of 7, you get a 3. So you'll notice our math matches from this point on. But if you didn't see that common base button, then the logarithm would work too. Okay, so you can still solve it the same way. It's still going to work. Unfortunately, that baby base method, while it is easier, it's not always helpful because you might get a question where you don't have a common base. Like in these next few, you're going to have, in this first case, a very strange base of e, which you are not going to be able to do anything with other than apply a logarithm. So some of you forgot to do this on the last time we tested this. You can't apply a logarithm until you've isolated the base. So you're going to have to isolate first by subtracting a 3 on both sides. So you've got 2 times e to the x equals 8. And again, you're still not isolated. So, whoops, divide by 2, divide by 2. Finally, you have the base isolated. You have e to the x equals 4. So all of these steps right here, this was just isolation. Absolutely no algebra 2 happened yet. Now the algebra 2 happens. We're going to apply a logarithm. But remember how I said you can use natural log or log. Well, in this case, it would be much smarter for us to apply a natural log to both sides. Because the natural logarithm is a logarithm of base e. So you're going to have some cancellation happen right here. So you have x equals the natural log of 4, which is just something I should be able to crank in my calculator here. You got a button. Looks like IN, but it's LN. Remember, that's natural logarithm. And you get a 1.386-ish. Okay? So in that case, I purposely chose a natural logarithm to apply to both sides because I wanted it to cancel with the e. Now, 26, Wouldn't it be amazing if, you know, 7 and 25 had a common base and you could think really hard about it? It doesn't. So you're forced to use a logarithm. And there's no isolation needed here. So you have to make the choice as to whether you're going to apply a log or a natural log. And it really doesn't matter unless you have a base issue like we did in the previous question, where there was already an e, so we purposely chose a natural logarithm. If memory serves me correct, you guys like to use log, like common log. So I'm going to go ahead and apply the common log to both sides of the equation. So what we have here, guys, is, I'm going to rewrite it because it's kind of gross. So we have the log of 7 to the x power equals the log of 25. Why do we do that? Well, logs act like anchors and they bring exponents down. That's the most important property of a logarithm. So this now says x times the log of 7 equals the log of 25. And then remember, log 25, hideous number, log of 7, hideous number. I'm just solving for x. So my final step here is to divide by the log of 7. And now I'm going to have to type in my calculator, obviously, because I don't know what these are off the top of my head. Just make sure you are using the same kind of logarithm within your problem and you're closing the parenthesis after each one. So I'm going to get an x equals 1.654. These are rarely pretty answers unless you have a common base kind of a question, like we saw at the beginning. Or sometimes base 10 problems are nice. All right. I think that's it. So good luck on your test. This is our last official summative for the final, and I think we all could use some nice scores. Good luck, everybody.